Hello, Year 10. So before we get on to today's lesson, let's do a recall quiz just to make sure that we are solid on the knowledge that we're going to need to actually do today's lesson. Okay, so here are your answers. If you are getting any of these wrong, I would say it's worth having a quick look back at last lesson just to make sure you are confident with the equations and the terms, specifically questions 1, 3 and 4. We're not too worried about question 2 today, but question 1, 3 and 4 are going to come up a lot, so make sure you are confident on them. Okay, so today is a core practical lesson. Now, I have done my best to make a video of all the sections of this practical. I should warn you that the volume in the recordings is a little low, so I would reckon if you've got headphones, put them in and get the volume quite high, just to make sure you can hear everything that I'm saying.
Okay, this is the first core practical from the P4 Waves topic. It is the Ripple Tank core practical. So let's have a look at the equipment that we've got in detail. So before we get into the nitty-gritty of this, let's have a look at the equipment that we've actually got. Because if we don't understand how this works, it's going to be really difficult to talk about improvements and errors. So the first thing we've got is the actual tank itself, this blue sort of frame with a glass bottom. Its whole job is just to create a little shallow pool of water, all right? And that is what we're going to create our ripples in. The next key part is this. This is our motor. This is what's going to make the ripples. So at the back, you can see there's a little gold spinning thing. Basically, this is like a little disproportionate weight at the back. And as it spins, it's just going to cause this grey thing to bob up and down. Okay? And when it bobs up and down, it's going to cause the ripples in our water. There is a controller at the back that I can turn up and down to speed it up. Okay? But as you can see, if I turn it up really, really high, actually, I haven't got a hope in hell of actually being able to measure anything in this water right now. So I'm going to turn it down nice and low to try and create some really distinct ripples that are easy to measure. Okay? And the last part is this light. Now the light is designed to shine through the water onto the paper underneath. And the reason we're doing this is because actually when the light shines through the paper, it's going to refract and we're going to get dark patterns on the paper, which makes it way easier for us to actually measure some of the properties of our waves. Right, so what I've done now is I've turned all the lights off so that I can actually see my ripples under the ripple tank. Now, although right now you might be struggling to see them, I'm just going to move the camera and you should get a much clearer view of what we're actually seeing. Right, so you can see now the ripples on this paper are so clear. Alright, yes, you can see reflection from my camera, which is somewhere here, and the light which is there, but still, the ripples on this page are so clear, making it way easier for us to actually measure the way they're moving. If we try to do this in the water, naturally water being transparent, or at least semi-transparent, it's going to be so difficult. This is so much easier now.
Right then. So now that we know how this works, let's have a look at the actual point of it. So the whole point of this core practical is to be able to measure the speed of the waves in different materials. So obviously today we're looking at liquids. There is a practical later where we're going to do it in a solid, but of course we'll save that for another day. So we're going to use both of the equations that you learnt in your last lesson. So the first equation is the one that we've used since year 9. All right, distance divided by time, that's nice and easy. And the second equation that we can use to measure the speed of these waves is frequency times wavelength. So we are going to be today trying to measure the 4 different things in these equations that will allow us to calculate the velocity: distance, time, frequency, and wavelength.
So if we are using the speed equals distance divided by time equation, we are going to need to be able to measure the distance and the time of our ripples. Now, as you can imagine, this is going to be pretty difficult because these ripples are moving quickly, but we're going to give it a go and we'll see what we can get. So the first thing we've got to measure is distance. Now granted, I could try and use the ripple tank itself and measure from one end to the other. I could try that, but that's going to be very difficult. And remember, we've got this light on to make our ripples look a little bit more obvious. So what I'm going to do instead is I am going to use this ruler. I'm going to put one dot at 0 centimeters, and I'm going to put another dot at 20 centimeters, which has just slightly gone off the screen. Let me just move the camera. There we go. You can see both dots now. Alright, now the reason I've done that is because this way I know that my distance is exactly 20 centimeters. If I had put them on randomly and then tried to measure them, I could get all sorts of readings, okay? And it could be 20.5 or 20.6. This way I know it's exactly 20 centimeters. Now granted, normally I wouldn't do it in felt tip pen either, but I'm doing it just to make it more obvious. So we've got our distance. So I'm just going to write on there now that from there, where's my other dot gone? There it is, to there, just to remind me, is 20 centimeters, which of course is 0.2 meters, because we do have to convert it. We cannot leave this in centimeters. That is not our SI unit. Right, now that we've done that, all that's left is for me to time it, because that's the other part of our equation. So I've got my trusty stopwatch here, and I'm going to do my best to start it when a ripple gets to there, so a dark part gets to that, and I'm going to try and stop it when it gets to the other side. Okay, so here goes nothing. Oof, I've got 2 seconds. That is quite a lot. .92. That seems a bit better. .99. Now I'm going to discard that one because I'm starting to think that that's an anomaly. So let's do another one. 0.89. Great. So I've got 3 readings there. Hopefully that will be enough to eliminate at least some of the errors, but as you can tell, these ripples are moving incredibly quickly, and human error is going to play a massive part in the issues that we're going to face with this data.
Right then, so let's have a go at actually calculating using the information we had gathered during the practical. So we had found that the distance was 0.2 meters. I apologize for the handwriting, I did it on a mouse. And the time, we measured 3 different times. We measured 0.29, we measured 0.99 and 0.89. So what we need to do is find an average. So I'm going to add up our 3 measurements and divide it by 3, which gives us an average of 0.93 seconds. So now that we've got that, we can plug these straight into our equation. So there's our equation. The speed or velocity is the distance divided by the time. So distance is 0.2 divided by 0.93, which gives us an answer of 0.215, which I'm going to round to 0.22 meters per second. And that, for the first part of this core practical, is job done. Okay, just to summarise then the first part of this core practical, have a go at these questions. The answers are on the next slide. Obviously, if you get them wrong, it's probably worth going back to the video and the slides before this and doing a bit of a recap.
So the second equation for wave speed is that the velocity of the wave is equal to the frequency times by the wavelength. Okay, so there's 2 things I need to measure to find the velocity. I've got to measure the frequency, which if you think back to last lesson is the amount of waves that pass in 1 second, and the wavelength, which is the distance from one peak to the next peak. or the length of a whole wave, because it could also be trough to trough, or a similar point on one wave to the same point on the next wave. Okay? So, let's have a go at measuring the frequency. So let's pick a point. Just put a little point here on the page. And what we're going to do, I am going to start the stopwatch, and I am going to time 5 seconds. And what I want you to do at home is try and count how many waves go past that point in that 1 second. I'm just going to slightly move this because I feel like the points are slightly clearer over there. So let's just move this. There we go. That's a little easier. So I'm going to do it for 5 seconds. Okay, you're going to count for 5 seconds, and then what we'll do is we'll divide it by 5 to find out how much in one. Okay, so get ready to count. 3, 2, 1, go. Okay, I went a little bit over. How many did you get? Write it down quickly. And then we're going to do it again, just to see if you get a similar result. Okay, get ready to count in 3, 2, 1, go. Okay, stop there. So, you did that twice. Now, were they similar? I would imagine they're probably not. And I would also imagine that you found it incredibly difficult to measure the amount of waves going past this point in 1 second. These waves are moving so fast, okay? It's going to be very, very difficult to get an accurate measurement of the amount of waves travelling past in a second. Now granted, if you did get a decent measurement, let's imagine that you measured 14 waves in 5 seconds. Alright, to find out the frequency, all we need to do is do 14 divided by 5, and that would give us our frequency, which is 2.8. Okay? So, you know, that isn't too bad if you can get a decent measurement of your frequency, or the amount of waves that go past. Alright, but as we've said, it's very, very difficult. So let's have a look at the other thing we need to measure. Let's have a look at wavelength. So if we want to measure the wavelength, I need to measure from one peak to another peak. So I'm looking at the idea of trying to go from maybe one dark spot to another dark spot on my paper. Now instantaneously, I'd imagine you've all realised that this is going to be incredibly difficult. Because actually, these things again are moving so fast. How am I meant to get a ruler and move it along with the ripples and try and measure accurately the distance from one peak to the next peak? I pretty much can't do it. Way too quick. So let's have a think about what else we could do to get a more accurate measurement for our frequency and wavelength.
Right then, same again as the last progress check. Let's just do a bit of a recap on this section. So we're recapping how we measure the speed of a wave using frequency and wavelength. And as before, mark it using the next slide and go back if you get things wrong to recap.
Okay, so now we've had a go at using the equipment. Let's have a quick think about the errors that we've just faced. So, in terms of human errors, so random errors, there are loads. So, measuring the distance was okay, but the time was incredibly difficult, because trying to pick out when it went past one point and got to the next point was very, very difficult. Trying to count how many waves went past in 1 second was just as difficult, again, because they're moving too fast. And the last thing we tried to measure was the wavelength, which was even more difficult, because not only are the waves moving fast, and I've got to start it on one wave, but I've got to somehow find a way to then measure how far it is to the next wave while it's moving. Incredibly difficult. So what we need to do now is have a different approach to how we're going to measure this. So to improve this then, the easiest thing we can do is to try and slow this down. Now granted, doing this in real life is quite difficult, but I can do it using a camera. So what I can do is I can simply record it instead of actually doing it, and then I can play that back in slow motion. And in addition to that, if I put the stopwatch in the camera view, I can play the stopwatch, which will allow me to keep track of time, so even though it's in slow-mo, I can see exactly when things are happening. So I can pause the video and play the video, and look at my stopwatch to get the exact amount of time that is passing.
So as we said, we need to come up with a better plan for how to do this, and this is what we're going to do. So we're going to measure frequency and wavelength again using some improved methods. We're going to use a slow motion recording to help us count the waves, so just to slow them down enough that they're actually, countable. And then we are going to use a picture to measure the wavelength, because obviously if the waves are moving, even in slow motion, it's still going to be fairly difficult to measure from one peak to the next. So the best thing to do is just to stop them entirely. And as long as we've got a ruler in the picture, we should be able to measure from one peak to the next fairly easily. So let's have a go. So let's have a go at using this equation now. I'm going to have a go at it with different made up numbers, simply because on the next slide you are going to have a go at doing it again yourself using the values that you actually collected from the equipment. So let's imagine that I measured my wavelength as, I don't know, 0.05 meters. Okay, and my frequency was, let's go with 60-ish. All right, so I've counted that. That 60 was in 5 seconds. Okay, because that's how long the video was. So of course that actually means that my frequency is 12 in 1 second, because I've just divided 60 by 5. So my frequency is 12 Hertz. All I need to do now is substitute that into my equation. So the velocity of my waves is the frequency. So that 12 will go into the first part of the equation. The 0.5 will go into the second. So I get 12 Hertz multiplied by 0.05. Wow, my mouse controller is getting pretty bad. Okay. And again, as always, use a calculator, because you are always allowed one. So I will use my calculator, which gives me a velocity of 0.6 meters per second. Okay, job done. Right then, so this time do the same method that I did on the last slide, but this time have a go at doing it with the values that you collected from our improved practical. Okay, another progress check. Now this time we're going to look at the errors and also how we improved it. So as always, have a go. The answers are on the next slide. If you have any issues or any mistakes, go back through the slides, go back through the videos, and make sure that you are rock solid on this before moving on. Okay, so last part of today's lesson then. What I would like you to do is to make a revision card to summarize this core practical. There are many ways obviously to do this. Those of you in my class, you'll know that we've been using the T method quite a lot for this, and you quite like the structure of that. But obviously you might have different ways of doing your revision cards, and by all means do what suits you, but do make sure it is organized. There is quite a lot of information to put onto this revision card, so make sure you plan it properly. Once you have done your revision card, just submit to your teacher a picture of the revision card and of all the questions and answers that you have done during today's lesson, so that they can help you and adapt how they move on to best suit how you've got on with today's lesson. Well done today, guys. In the next video we'll have a look at the next core practical. Take care.